Alright, hello everyone. Today we are gonna look into a concept of instrumentation called scaling of instruments. You might have came across many kind of instruments like a pressure transmitter like this or a flow meter like this. Every time we purchase any process instrumentation, we get that instrument with a certain spec, and those specs are like the process instrument will go from one value to other value, and while going from one to other value it gives a signal. In this case, let's consider that this pressure transmitter is giving a signal of 1 to 5 volts whenever it is going from 0 to 5 psig. Similarly, this is a flow meter which can go from 0 to 100 SLM for a voltage of 1 to 10 VDC. So most often whenever we design a microcontroller or a PLC or any control system, we need to tell that control system that okay, if this is a control system and a pressure transmitter is attached to it, and we know a certain spec of pressure transmitter as shown here, and if the pressure transmitter is reading 3.2 VDC, how the control system will know that what the pressure is, or how it will convert this uh, 3.2 volts of signal to equivalent pressure. So this process is called scaling of instrumentation, where you scale the instrument or basically predicts a model of the instrument which relates the process variable and signal. So this process is called scaling of instrument. So we'll take an example of this pressure transmitter. Let us assume that this pressure transmitter is connected to a pipe here, and in this pipe the pressure varies from 0 to 5 psig, and this pressure transmitter is rated for 1 to 5 volts DC. Yeah, so before we proceed, right now we are only talking about linear instrument. What our linear instrument basically is, like if you plot their process variable like pressure in this case and signal, with the increase in the process value like 0 to 5 psig, the signal increases linearly, like it obeys the mathematical equation of a line, which is nothing but y equals mx plus c. So where m is the slope and c is the offset. We'll look into that. So if you have a instrument whose process range is known and whose signal range is known, how you will find out this equation? So it's very simple. If you look into this equation, y is equals to mx plus c, here y denotes the process variable or the pressure in this case. X is the signal, and what is this m and c? So c is offset. Basically it's the response of the system when there is no signal available, and m is the gain. Gain is the relation between the pressure and the signal, or the process variable and the signal. So let's inject this data into this equation here downside. So we know pressure from this data. What we can say that when the pressure is 0, we don't know the gain in this case, so let's gain be g multiplied by what's the signal. Signal when the pressure 0 is 1, and plus offset also we don't know. Let it be OF for now. So the objective here is to find out the gain and the offset value, so that we can finally get into this final equation, which we can feed into any microcontroller, PLC, or anywhere wherever it's required. From this data again, we can say that when the pressure is 5 psig, that time we don't know the gain, and that time the signal is 5 volts, and offset we don't know, so we'll keep offset. So if I give this equation 1 and this equation 2, and I subtract equation 1 from equation 2, what I will get is basically, or let's write it down in that form first of all. 5 is equals to 5g, g is nothing but gain plus offset, and 0 is equals to 1 into gain plus offset. So let's subtract both of these equations. It's basically solving these equations. You can solve it by any method. Now I'm gonna subtract it simply. So 5 is equals to 4g minus 0. So from here I can find out g is equals to, plus that g is equals to 5 by 4, which is 1.25 psig per VDC. So if you look closely here, the value of g is 1.25 and the unit is psig per VDC. So it is the response of the system in terms of basically not the response, it's the relation of the output of the system and the input of the system. The output of the system is psig, and the input which the the pressure transmitter is giving as a signal is VDC. So it basically correlates what is the psig per VDC. So, and if we inject the same value of gain in any of these two equations, like if I put the value of g from here to, let's say, here, what I'm gonna get is 0 is equals to 1 multiplied by 1.25 plus offset. So offset will be minus 1.25 psig. So that is how we find out the gain and the offset. Once we have these two values, it's very easy to use the equation of a linear instrument and predict the pressure at any value. So as we know from here that pressure is gain multiplied by signal and plus offset. So we can write down pressure is equal to gain into signal plus offset. So now we know that gain is nothing but 1.25 and offset is minus 1.25. So we can write 1.25 times signal plus offset is basically minus 1.25. So we can directly write it minus 1.25. So this is how the pressure and signal is related for this pressure transmitter. Now let us say that we want to find out if the signal of the pressure transmitter is coming out to be 3.2 VDC, and we want to find out what the pressure is. So we can write it here, 1.25 multiplied by 3.2 minus 1.25, and if you will calculate this, 1.25 multiplied by 3.2, you will get 4, and then you again subtract 1.25 from it. It is 2.75. So this terms comes out to be 4 minus 1.25, so it will be 2.75 psig. So this much pressure is equivalent to 3.2 volts. So basically in this process, what we have learned that in any instrumentation, like if you have any instrument and you have its process value, process range and signal range, what you can do is you can find out its gain and offset. How to find out is very simple, like you can form linear equation in two variable as I have shown you here in this section, but there is a direct formula also, that is gain equals to process max minus process min, like the process value maximum, the range maximum, range minimum, and signal max minus signal min. You need not to remember this formula, but sometimes it's handy to find the gain like this, and then simply put this gain into this equation. Process variable equals to gain into signal plus offset. Find offset, like basically find the gain and the offset, and then put it into this equation, and you are good to go. Your instrument will feed the signal here. Your microcontroller will be having this equation inside. The value of gain and offset you have already fed to this, so it will it always comes to know what's the process values. You can do it for any linear instrument, whether it is pressure transmitter, temperature transmitters, flow meters. Now temperature transmitters, linear temperature transmitters are there, but it do not work for NTC, like thermocouples, thermistors and all. So that's all. If you have any question, please write it in the comment section. I'll try to reply. Thank you again.